Hi everyone, I am Shingval and welcome back to my YouTube channel. Now we are going to see the second question of today's Leetcode Biweekly contest 171, which is minimum operations to make binary palindrome. Okay, so let's see what is this question and how we can solve it. So in this question, you are given an integer array nums, and for each element nums I, you may perform the following operations any number of times including 0. Okay, what operation? You can increase nums I by 1 or you can decrease nums I by 1. Okay, a number is called a binary palindrome if its binary representation without reading zeros reads the same forward and backward. Okay, and your task is to return an integer array answer where answer I represents the minimum number of operations required to convert nums I into a binary palindrome. Okay, so what you have been given in the question is that an integer array nums, and you can perform operations on nums I any number of times. What operation? Either you can increase nums I by 1 or you can decrease nums I by 1. Okay, and a number is called a binary palindrome if its binary representation of nums I is a palindrome number. Then that number is termed as a binary palindrome. And what you need to do, you need to return an integer array answer where answer I represents the minimum number of operations you need to perform on nums I to convert it to a binary palindrome. Okay, so let's try to understand this theoretical thing with the help of some test cases. So you have been given with an integer array nums 1 to 4. Now let's check for 1. Okay, now let's convert it into its binary representation. Okay, its binary representation is also 1. So is it a palindrome or not? Yes, it's a palindrome. So you don't need to perform any operation on this. So your answer will be 0 for this. Okay, now let's go to 2. Okay, so let's convert it into binary representation. Its representation will be 1 0. Okay, is it a palindrome number? No. Okay, now let's check for 3. Its binary representation is 11. Yeah, it's a palindrome number. So you can increase by 1 and the number you will get is a binary palindrome. So your answer will be 1 for this case. Okay, now let's check for 2 whether it's a palindrome, binary palindrome. No. Okay, either you can increase it by 1 or you can decrease it by 1. Okay, so let's try decreasing it by 1. We will get 3 and 3 is a binary palindrome. So your answer will be 1 for this case as well, because you have been given that you need to return the minimum number of operations required to convert nums I into binary palindrome. Okay, let's first understand the second test case, then I will tell you what I misunderstood in this question initially and then got to know with this second test case. And let me know in the comment section either you also understood this question in that way or not in that way. Okay, so in this you have been given with 6, 7 and 12. Okay, so let's convert 6 into its binary representation 1 1 0. Okay, let's decrement 6 by 1. Okay, 5. 5 by, in what is the binary representation of 5? 1 0 1. Is it a palindrome? Yes. So your answer will be 1 for 6. Now similarly for 7, let's convert it into the binary representation. Okay, it will be 1 1 1. It is already a palindrome number. Now this 111 is already a palindrome, so your answer will be 0. You don't need to either increase or decrease this number. Okay, now let's go to 12. Okay, so here 12 is 1100. So you can check for 13, 11 or 14 or 10. You can check for those numbers and then you will get 15 as your nearest number. It means you will need to increase it by 3 numbers, so that's why your answer is 3. Okay, now what I understood this question initially was, so let's say your string is 1100, your integer is 12 and your binary number is 1100. So what I understood is that let's check in this string whether this is a palindrome or not. Okay, so how you can check? Okay, let's match these two numbers. Oh, these are not equal, so either I can increase it or I can decrease this number. Okay, so this will be your one operation. Now similarly I will check for these two numbers. Okay, these are also not equal, so either I can decrement this or increment this one. Okay, so this will be another operation. So either it will be 0 0 0 0 or 1 1 1 1, but my operations will be 2. I thought that I need to apply the operations on this binary string. No, you need to apply the operation on this integer itself. You need to either increment 12 to 13 or decrement 12 to 10, or increment it to 14 or decrement it to 10. Here it was 11. Not like you need to check for the string, like how many operations you can make that string palindrome. No, you don't need to check this thing. You are asked to update that integer itself. So maybe I read that question wrong, that's why I understood it in this way, but this is the correct meaning of increasing and decreasing the integer by 1. Let me know in the comment section if you also understood this question in this way. But yeah, okay, now how to approach this question so that we can write its code. Right now we understood what is this question and what is it asking for, but now let's try to understand how we can solve this question. Okay, so let's say if you have been given with this integer array nums, right? And you need to return an answer array representing the minimum number of operations you need to perform on each number, so that they are binary palindrome. It means their binary representation should be a palindrome string. Okay, so what you can do, first you need to check whether, obviously you will need to iterate on this array, right? Otherwise how you can check for every integer? That's for sure. You will need to iterate on this array, right? 0 to n, and then you need to check for each number whether that is a palindrome, binary palindrome or not. So let's say if is binary palindrome nums of I, right? So if this number is itself a binary palindrome, then let's say if you have initialized your result, then you can simply push a 0 in your result, right? Otherwise what you will do, you will need to check whether, let's say, either you can increment that number by 1 or you can decrement that number by 1, and you need to get the minimum number of operations. So let's say if you have 1, then you can keep on checking 1, 2, 3, 4. Then how you will check for the numbers less than that, how you will decrement it? So what we can do, we can increment and decrement them simultaneously. So if we, let's say if we have already checked that if nums of I is not a binary palindrome, so let's say if your number a is not a binary palindrome, then what you will do, you will check for a minus 1 and a plus 1. You will check for both of them, and if it is also not, then obviously you will increment your operations by 1, because you have already either decremented or incremented that number by 1. If now let's check for a minus 2 and a plus 2. If it is also not, then again you will have to increment your operation. Basically what we are trying to do here, we are trying to increment and decrement that number simultaneously, so that we will be able to get our minimum number of operations. Okay, and how many times we need to run this loop, we don't know right now in the starting of this loop, right? So what we can do, we can initialize a while loop and give its condition as true, and we can check if is binary palindrome of a minus 1, or you can say nums of I minus 1, I'm just typing the pseudocode, or is binary palindrome of a plus 1, right? If it is true, then what you will do, you will simply increment your operations, push your number of operations in your result, and just break this loop, because you have got your answer, right? Otherwise what you will do, you just need to increment this value, right? So what you can do, you can initialize this integer I as 1 initially. Let's say this is I. Otherwise what you will do, you will just increment your I, and in the next loop you will keep on checking for a minus 2, a minus 3, a plus 2, a plus 3, and so on, right? And by the end of this iteration, of this for loop, you will simply return your res. Okay, now the question comes, how you will implement this is binary palindrome function, right? So what you are passing in this function is an integer, right? So how you will implement, how you will check whether this number is binary palindrome or not? So for checking for its binary palindrome, first what you will do, you will convert this nums of I to a binary string, right? So how you can convert a string to its binary string? So let's say if you have 4, then how you can convert it to a binary string? So let's take its modulo by 2, right? So its modulo by 2 is 0. Okay, let's initialize our string as, and let's add the its remainder in this string. And what will be its 4 by 2? It will be 2. Okay, now let's again take its modulo by 2. It will be again 0. So you will again add this into your string, and now again take its quotient by 2. So it will be 1. Okay, now it is still greater than 0. Now again take its modulo by 2. So now it will be 1 and your quotient will be 0. So your 1 by 2 will be 0. Now you have came to the end of your loop. Basically we will keep on adding the remainders, and by the end of the iteration we will simply reverse this string and you will get your binary representation of your integer. So in this way you will be able to get your binary representation. Now what you can do, you can simply apply a for loop from I is equals to 0 till I is less than or equals to n by 2, and you keep on incrementing I, and check if, let's say this is a s of I is not equals to s of n minus I minus 1, then simply return false. Otherwise, after coming out of this loop you can return true, right? So in this way you will be able to check whether this string is a palindrome or not. Because in palindrome, what you need to check? You just need to check whether this first and the last number are equal. Let's say if you have a string something like 1 0 0 0 0 1 0, right? So what you will check? You will check this number with this number, this number with this with this, right? And so on. So it's just we are checking first with the last number, second with the second last number, and if any one of them is not equal, it means that string is not a palindrome string and you will return false. If this condition was never true in this iteration, it means that string is a palindrome string and you will return true, right? So I think you got like how you will implement this is binary palindrome function. First you will convert it into a binary string and then we check whether that is a palindrome or not, right? So this is the complete pseudocode for this question. I hope you get it. Now don't go jump to the code directly. First do pause this video and try to code it on your own, because I have already written the complete pseudocode and its code is also quite similar as this. So what we are simply doing in this question is we are iterating on this string and we are checking whether that number is a binary palindrome or not. If not, then we are simultaneously incrementing and decrementing that number and checking whether those numbers are binary palindrome or not. If yes, then we will simply break this loop. Otherwise, we will keep on checking for further numbers. Okay, now let's move forward to its code. Now let's start from this function minimum operations. So let's first start iterating in our array. We have initialized our result vector, and initially our operations are 0, right? And let's say our nums of I is num, and if it is a binary palindrome, just directly push 0 operations in your result vector. Otherwise, initialize I with 1 as while loop as true, as we have already seen, and then simultaneously decrement and increment your number. And if you have got that your number is binary palindrome, then simply increment your operations and push the operations in your result and come out of this loop. Otherwise, just increment your I. It means you need to increment and decrement those numbers and increment your number of operations, and finally you will return result. Now let's see how we have implemented is binary palindrome. So this is a boolean function. First it will convert decimal into binary, and then we'll check whether that binary representation is a palindrome or not. Okay, now let's implement these two functions. So similarly, for decimal to binary, we will keep a check till n is greater than 0. Keep on taking the modulo and adding the modulo into our binary number, and keep on dividing n by 2, and by the end we will reverse our string. So we will get our binary representation, and we will check for that whether that is a palindrome or not by checking the first with the last number, second with the second last, and so on. Okay, so now let's talk about its time complexity as well. Like let's start from very starting. So like we are having this for loop, so it will take n complexity, right? We are running this loop till n. Now the complexity of this is binary palindrome comes. Okay, so now let's check the complexity of is binary palindrome. Okay, it is just calling these two functions. So let's see the complexity of these two functions. Okay, so it is dividing our integer by 2 every time. Its complexity will be log n, right? Log base 2n every time, because we are dividing it by 2, or you can say the number of digits present in your string, and that will be log n, right? Okay, now let's check for the complexity of this is palindrome function. So it will also be the number of digits present in your binary number. So how many digits will be present? So let's say d. So obviously the number of times this decimal to binary function runs will be the number of digits present in your binary representation, right? Because here we are converting your decimal to binary, and this loop runs log n times. So obviously the number of times this is palindrome function will run will be log n, because it will run on your binary string, right? And this is the representation of your decimal number. So the number of times this loop will run and the number of times this loop will run will be same. Okay, so your complexity of is binary palindrome will be log n, and this is binary palindrome is also called inside a while loop. And what can be the complexity of this while loop? It, in worst case, it can go up to, let's say for average case it will be x, and its binary palindrome is log n, right? But in worst case, what it can be, let's say if your num is 5000, right? So in very worst case, it can go up to 0, obviously. So it can be any worst case, but I don't think it is going to be true for any such case. So you can say its time complexity will be n into x into log n. So yeah, that's it for this question. I hope you get it, and if you still have any doubts, you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.